Okay, today we are going to figure out how to find the inverse of a 2 by 2 matrix. The first question we want to ask is, how do we know that two by 2 matrices A and B are inverses? And the way we know if we have multiplicative inverses is if when we multiply them both ways, in other words, if we do AB and BA, we get our multiplicative identity 1, 0, 0, 1. The multiplicative identity has to be a square matrix with all zeros with ones running along the diagonal going from left to right. So let's multiply our two matrices here to see if we have multiplicative inverses. We'll call the first one A and we'll call the second one B. Remember, if at any point you get behind in the video, you can always pause it to catch up and rewind to go back. So we're going to do the first row times the first column. And we have 7 times 1 plus 2 times negative 3. This will be my work. And that will give us 1. And then we're going to do the first row times the second column. And that will be negative 7 times negative 2 plus positive 2 times 7. And that's 0. I'm going to stop doing work at this point because I see a pattern. This is A, B. Alright, so now I have 3, 1, and 1, negative 3. Well, that's going to be 3 minus 3 is 0. And then I have 3, 1 times negative 2, 7. It's going to give me negative 6 plus 7 is 1. Yay! So the first one works. Let's check the second way. It's got to work both ways. Alright, so now I'm going to rewrite this because I don't want to get confused. I have B. Here's B. And A. 7, 2, 3, 1. So now I'm going to do BA. So I'm going to have first row, first column, and that's going to give me 7 minus 6 is 1. And then first row, second column, 2 minus 2. If the multiplication is going too fast, please go back and view the video on multiplying matrices. Now we've got 3, 7, and 7, or I'm sorry, negative 3, 7, and 7, 3. Well, that's going to give us negative 21 plus 21. And then we've got negative 3 times 2 is negative 6. 7 times 1 is 7. So, yay, we have just proven that A and B are inverses. Because both sets of multiplication gave us our identity. So our question is, if we're given A, how can we find B? How can we find that multiplicative inverse? When we're finding the inverse of a matrix, we need to first find its determinant. All right. If we have a square matrix, the way we're going to find the determinant is we're going to multiply AD, and we're going to subtract from that the product BC. And that number is what we call our determinant. And I want you guys to notice the way we show determinant is we have these little, they almost look like absolute value signs. So let's say, just for fun, we were looking for the determinant of my favorite matrix, 1, 2, 3, 4. The determinant of Mr. House's favorite matrix, 1, 2, 3, 4, is going to be 1 times 4 minus 2 times 3. So that would be 4 minus 6 is negative 2. That's how we find a determinant of a 2 by 2 matrix. If you need to pause the video to write this down, please do so now. Alright, now we're going to use our determinant to find the inverse of a matrix. So the inverse of a matrix ABCD is going to be A inverse equals 1 over, and I want you to notice that right here, that is our determinant. So 1 over the determinant times, and I want you to notice here we've rearranged matrix A a little bit. A and D have switched spots, and we've negated B and C. So A and D switch, B and C are negated. And provided that our determinant is not 0, because if the determinant is 0, we can't distribute this scalar of 1 over the determinant because you can't divide by 0. So, let's find an inverse, shall we? Slide this up so we have a little more room. Alright, so we have this lovely matrix, 2, 1, negative 5, negative 1. And we want to find A inverse. The first thing we need to do is find the determinant of A. I'm going to do that to the side. So we have the determinant of A. I want you guys to notice it kind of looks like absolute value, but it really means determinant when we're talking about a matrix. 2 times negative 1 minus 1 times negative 5. So that's going to be negative 2 plus 5 is going to be 3. Right. So we're going to have 1 over 3. And now we're going to rearrange. So 2 and negative 1 are going to switch. And we're going to negate 1 and 5. And now we're going to distribute. So we have negative 1/3, negative 1/3, 5/3, and 2/3. And that is going to be the inverse of matrix A. What I want you to do now is pause the video and find the inverse of these two matrices. Okay, to find the inverse of this matrix, the first thing we're going to do is we need to find its determinant. So, the determinant would be 1 times 7 minus 8 times 1. Ooh, this one is nice because it has a determinant of negative 1. So we're going to have 1 over negative 1 times switch A and C, switch A and D, negate B and C. Now we have a nice scalar here, just negative 1, so our inverse is just going to be negative 7, 8, 1, and negative 1. Okay, and now we have one more. If we find its determinant, that would be 6 times 3 minus 2 times 8. So we have 18 minus 16, which is 2. So it will be 1 over 2. 1/2 is our scalar. 1 over the determinant. Switch A and D. Negate B and C. And distribute. Please reduce your fractions. And so there is the inverse of example 4.